Hi, welcome to the last exercise of the Diels Alder. Okay, I wrote here the starting material, and what I did is to numerate all the structure, okay, in order to facilitate then the job. Basically, we have here a dienophile, okay, that is electron pool, and here we have the diene. First thing that we need to do is to draw it a little bit more properly to see how it's going on the reaction. I draw it in this way. I didn't change anything, the only that I put is the double bond and the diene, more or less facing one to the other, and showing that we are forming a 13-4 bond. We are forming this bond, and we are forming a 14-1 bond. Okay, we are forming these two bonds. What we need to do is to draw this compound in the right conformation. If we take a look, here is a 6-member ring, and here 1, 2, 3, 4, 5, 6-member ring. We are forming two 6-member rings. These are two 6-member rings. That what we can do is to draw it in this way, like a decaline. Okay? We draw it as a decaline. Okay? This is a decaline, and I will numerate. We know that this bond, this carbon has to be carbon number 10. Okay, because it's this one where we join that one. Then, if this is 10, this has to be number 5. This has to be number 4, and this is the bond that we are forming. Next one, this is number 6. 7, 8, 9, 11, 12, and this is 13. Okay, next we put the rest of the substituent. Here we have the A, and here what we have is the alkene with CHO down and metal. Okay, I will try to draw it a little bit better. Okay, but this is the reaction that we are doing. Okay, important things. Here the aldehyde is already in the endo position, that means it's good for us. And then I need to put the different substituents. That means carbon 8 is oxygen, carbon 6 is oxygen, then carbon 7 is the phenyl that is going up. Okay, in carbon 10, the hydrogen is going up. Okay. In carbon 5, the hydrogen is going down. Okay? What happens if this is not right? That means, that means in this decaline that I draw, the phenyl is already in a equatorial position. What happens if I draw it and I get the axial position? Well, then what I need to do is to draw the other possible decaline formation. That means instead to growing in this way, growing in this way, and you will see that you will change the configuration of the phenyl. Okay? And then the only that we need to do is to check this. Because I draw it like this, the diene is in front of the slide and the alkene will be in the slide. That means that we are forming this bond here, and I can draw it like the final compound. That means the final compound will be okay, and then oops. I will try to draw it a little bit better. I am able to draw it a little bit better. Okay, and again I have to numerate. I know that this is number 10, this is number 5, 6, 7, 8, 9, this is 11, this is 12, this is 13, this is 14, that means that this is 1, 2, 3, 4. Okay? I have all the numbers. And then we put the substituents. Oxygen here, the phenyl is going up. Okay, here the hydrogen is going up. Here the hydrogen is going down. And then we are forming this bond between 2 and 3. I will have the double bond, okay? And because I am forming this bond, this hydrogen is up, that means that this hydrogen will be up. Okay, next one, here the hydrogen is down, that means that this will be down. CHO will be down. If we are forming this bond, the CHO is going down, the hydrogen is going up. And if we are forming this bond, okay, the hydrogen is going up and the triple bond is going down. And this will be the final configuration. Okay, looks very complicated, and I will not lie, it's quite complicated, but it's because the structure is very big. My recommendation is always numerate all the structure. This will facilitate your life, will make your life easier. And then grow it in the way that you have the Diels Alder. And then check. Normally, because we know how to optimize the conformation of 6-member rings, normally we will form 6-member rings. Here we have a 6-member ring, here is a 6-member ring, and here is a 6-member ring. If we take these two 6-member rings, this is a decalene. That means we draw the decalene, okay, the structure of the decalene, and then we put the substituents. We check that the diene is facing the alkene, okay, one in front of the other, and then we put the substituent, the phenyl, the different hydrogens. Normally the phenyl has to be in an equatorial position. If it's not in an equatorial position, we have to regrow this molecule in order to put the phenyl in an equatorial position. Okay, in this case we did it at the first time, and then the only that we need to analyze is the two new bonds. Okay, like we do in a simple Diels Alder. Okay? Good. Thank you very much for your attention. Try to do it at home, try to do it very slowly, try to do it with molecular models, and you will see that with some practice you will be able to do it. Okay? Thank you very much, and see you in the next lecture.